Good morning. It's March 17th, and this is your daily brief in science. Here's everything you need to know. Engineers at NASA's Ames Research Center are making strides in the development of a heat shield for a groundbreaking mission to Venus, led by Rocket Lab in partnership with the Massachusetts Institute of Technology, or MIT. This mission marks the first private spacecraft aimed at exploring the planet's atmosphere. Sarah Seeger, from MIT, who leads the Morningstar missions team, has confirmed that integration tests with the spacecraft have been successfully completed, indicating significant progress. The spacecraft will now be launched using Rocket Lab's neutron booster, a shift from the previously planned Electron launcher, which ties the mission's timeline to the neutron's readiness. The launch, originally scheduled for January 2025, has been postponed to a summer 2026 window, as confirmed by Seeger. Central to this mission is the heat shield, known as HEEET, a textured, woven material developed with support from NASA's Small Spacecraft Technology Program. This heat shield is crucial for protecting the spacecraft during its entry into Venus's harsh atmosphere. Rocket Lab's Venus probe is designed to explore the planet's clouds for potential signs of life, collecting vital atmospheric data during its descent. HEEET can withstand extreme temperatures of up to 4,500 degrees Fahrenheit, making it essential for the probe's atmospheric entry. NASA's collaboration with private companies like Rocket Lab not only fosters innovation in spacecraft design but also contributes to the growth of the space economy and enhances our understanding of Venus. Researchers from TU Graz have launched a groundbreaking project named Estimation, which aims to repurpose signals from communication satellites, including Starlink, for climate research and Earth monitoring. This project utilizes the Doppler effect, a phenomenon that alters the frequency of waves based on the relative motion of the source and observer. By leveraging this effect, scientists can measure changes in the Earth's gravitational field, providing valuable insights into environmental shifts. The researchers are focusing on detecting subtle shifts in satellite signals caused by variations in sea levels, groundwater, and ice masses. This approach allows them to create detailed maps of environmental changes. If successful, the method could provide real-time data on extreme weather events, sea level fluctuations, groundwater depletion, and ice mass changes, complementing traditional geodesy missions. Utilizing existing communication satellites represents a significant advancement in geodetic science. These satellites offer higher temporal resolution compared to navigation satellites, making them more effective for detecting short-term climate changes such as heavy rainfall. Despite facing challenges, researchers have identified consistent frequency tones in Starlink transmissions, achieving an estimated positional accuracy of 54 meters, indicating the method's potential. However, the research is hindered by the lack of publicly shared signal structures from satellite operators and the absence of precise orbit data, which can introduce errors in calculations. To enhance accuracy, the navigation research team is developing advanced signal processing techniques and mobile tracking antennas. Their goal is to improve positioning accuracy to a few meters by employing advanced antennas and multiple measurement locations. Philippe Bergles from TU Graz emphasizes that the method focuses on tracking satellite movements rather than decoding message content. This focus enhances our understanding of Earth's gravitational field and climate dynamics. Overall, new signal processing techniques are being developed to extract more precise data, which could significantly enhance tools for monitoring climate changes. Astronomers have made a significant discovery with the identification of two planets orbiting the binary star system TO1-1453, located about 250 light-years away in the constellation Draco. Among these planets, TO1-1453b is classified as a rocky super-Earth, while TOI-1453c stands out as an unusually light sub-Neptune. Measuring approximately 2.2 times the size of Earth, TO1-1453c has a notably low mass of 2.9 Earth masses, making it one of the least dense sub-Neptunes discovered to date. The orbital configuration of these planets shows a near 3:2 resonance, indicating a dynamic interaction that could provide insights into planetary system formation processes. This discovery contributes to our understanding of planetary formation and evolution, revealing configurations that are common throughout the Milky Way. TO1-1453c has been earmarked as a prime target for advanced telescopes, such as the James Webb Space Telescope, which will investigate its atmosphere to gather further insights into its formation and evolution. The low density of TO1-1453c suggests it may have a thick hydrogen-rich atmosphere or a composition primarily made up of water, making it an excellent candidate for future atmospheric studies. The sizes of these planets were determined using the transit method from NASA's Transiting Exoplanet Survey Satellite, or TESS, which observed dips in the star's brightness. Meanwhile, the HARPSN spectrograph monitored the star's motion to establish the planet's masses. These types of planets are common in the Milky Way but are notably absent from our solar system, highlighting the importance of this discovery for comparative planetary science. Future observations with the James Webb Space Telescope will aim to analyze TO1-1453c's atmosphere, enhancing our understanding of its composition and the implications for sub-Neptune formation. A new treatment for urinary tract infections, or UTIs, is making waves in the scientific community. Researchers have developed a method using nanogels to deliver antibiotics directly to infected bladder cells, significantly improving effectiveness over traditional treatments. This innovative approach combines nanogels with a specialized peptide to rapidly deliver gentamicin, an antibiotic, directly where bacteria flourish in the bladder. The design of these nanogels allows for a quick release of gentamicin, accelerating the elimination of bacteria. Research led by Humberto Escobedo at the University of Colorado Anschutz Medical Campus found that these nanogels can carry 36% more gentamicin than conventional delivery methods. In laboratory tests, this technology demonstrated minimal harm to healthy cells while effectively killing over 90% of UTI-causing bacteria. Published in the journal Nanomedicine, the study indicates that this method can eliminate over 90% of bladder bacteria in animal models. Senior author Michael Schur highlighted the need for improved UTI treatment options, noting that these infections are common, costly, and can severely affect patients' quality of life. Co-author Devatha Nair emphasized that this new method minimizes side effects and lowers the risk of antibiotic resistance, addressing concerns related to prolonged antibiotic therapies. The research involved collaboration across disciplines such as polymer chemistry, pharmacology, and microbiology, enhancing its potential for human application. The study was funded by the National Institutes of Health, representing a significant advancement in developing long-lasting treatments for infections. Clinician scientist Marcia K. Guess played a role in maximizing the method's applicability in clinical settings. This innovative drug delivery system could also have potential applications beyond UTIs, with initial ideas stemming from treatments for periodontal disease. A recent study has raised significant concerns about the safety of disposable diapers, revealing that they are a major source of phthalate exposure for infants. Conducted in Guangzhou, China, this research focused on 66 infants to investigate how these diapers contribute to dermal exposure to phthalates and the potential association with DNA oxidative damage. The findings indicate that a notable proportion of infants are exceeding safe exposure levels of phthalates through the use of disposable diapers, which could have serious implications for their development. The study established a positive correlation between the levels of diene-butyl phthalate, or DNBP, found in diapers and urinary mono and butyl phthalate, or MNBP levels, suggesting direct dermal absorption of these chemicals. Analysis of urine samples revealed that metabolites of D2-ethylhexyl phthalate, or DHP, were the most prevalent, indicating significant absorption of phthalates by the infants. Furthermore, urinary metabolites were positively linked to the oxidative damage biomarker 8-hydroxydeoxyguanosine, or 8-OHDG, highlighting a potential risk of genetic harm due to phthalate exposure. The predominant phthalate detected in the diapers was DEHP, with a median concentration of 1,670 nanograms per gram, followed by DNBP and other compounds. While the study provides critical insights, it also acknowledges limitations, including potential overlaps with other sources of exposure, and emphasizes the necessity for larger, more comprehensive studies to establish causality. It was estimated that daily uptake rates from dermal absorption through diapers constituted a substantial percentage of total phthalate exposure, particularly in younger infants. Phthalates, widely used as plasticizers, can leach from consumer products, posing significant health risks to vulnerable populations such as infants. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.